Sherelle is the goal shooter for her netball team. During her matches she has many attempts at scoring a goal. Assume that each attempt at scoring a goal is independent of any other attempt. In the long term, her scoring rate has been shown to be 70%. That is, 7 out of 10 attempts to score a goal are successful. What is the probability correct to 4 decimal places that her first 8 attempts at scoring a goal in a match are successful? Well, that's just going to be 7 out of 10, or 0.7 to the power 8. So that is just going to be 0.7 to the power 8, 0.0576. Correct to the 4 decimal places required. Exactly 5 of her first 8 attempts at scoring a goal in a match are successful. So she's going to have 5 successes. We could do this as a binomial if we wanted to, because we can say n is equal to 8, but we don't need to. So 0.7 to the 5, and that must mean that she had 3 failures. Now we don't know exactly where the successes occurred, but we've got 8 attempts and we're choosing positions for 5 of those. So this should give us the answer. So we want 8C5 multiplied by 0.7 to the power 5 multiplied by 0.3 to the power 3, and that's 0.2541. At least 5 of her first 8 attempts at scoring a goal are successful. I'm going to go to binomial here. So we've got a binomial with 8 trials, probability of success 0.7, and we're after the probability of x being greater than or equal to 5. So we can go to the calculator, and we've got discrete binomial CDF, and we're going from 5 up as far as 8 with 8 trials and a probability of success of 0.7. So 0.8059. Exactly 5 of her first 8 attempts at scoring a goal in a match are successful, given that her first attempt was successful. So what we have here is the probability that x is equal to 5 given that the first was a success. So that's the probability that x equals 5 and the first is a success over the probability that the first is a success. Now we know the denominator there is going to be 0.7. Numerator is going to be more complicated. As far as this bit's concerned, if we know the first is a success, then we're wanting 4 more. And that's going to be out of 7 trials. One in probability that y is equal to 4. So it's an and. Probability the first is a success is 0.7. And then we're going to want this. So this time it's a binomial PDF, just the one value. We want 4 given 7 trials. Probability of success is 0.7. So okay, that 0.2269. 0.7s cancel, and we just get 0.2269. Sherelle wants to ensure that her chance of scoring at least 2 goals in a match is above 99%. How many attempts at scoring a goal should she make during a match? Well, it's still binomial, but we don't know the number of trials here, and the probability of success is still the same. And we want probability of x being greater than or equal to 2 to be greater than 0.99, which means the probability of x being less than or equal to 1 is less than 0.01. Now let's think about the probability of x being less than or equal to 1. That's the probability that x is equal to 0 added to the probability that x is equal to 1, and that's less than 0.01. Now this one here would mean that everything was a failure. So that would mean 0.3 to the power n. This would mean one success, so we'd have 0.3 to the n minus 1 multiplied by 0.7, and of course there's n possible positions for the success. So we need to try and solve this. So let's go for a solve, and we've got 0.3 to the power x plus x multiplied by 0.3 to the power x take away 1 times 0.7, and let's put that equal to 0.01 and execute that. More solutions may exist. Negative solutions obviously not what we want. So we've got n is equal to 6.085, and the usual thing in these situations is that we need to increase by 1. So if n is greater than or equal to 7, then her probability of getting at least 2 goals will be 99% or better.